Last time, diagonalization looked almost civilized. Today, we test the matrix that refuses to cooperate. The point is not just that this one matrix fails. The point is that it fails in a very organized way. Mathematics loves ruining things, but neatly. Start with A equals the 2 by 2 matrix with rows 2, 1, and 0, 2. The characteristic polynomial is t minus 2 squared, so the only eigenvalue is 2, with algebraic multiplicity 2. Algebraic multiplicity says 2 copies are available. Now we ask whether the eigenspace actually gives 2 independent directions. Spoiler: it files a complaint. Subtract 2i. Solving the eigenvector equation gives y equals 0. So the eigenspace is only the x-axis. Its dimension is 1, not 2. The matrix asked for a basis of eigenvectors and received one lonely direction. A two-dimensional space needs 2 independent eigenvectors for diagonalization. Our eigenspace has dimension 1. Therefore this matrix is not diagonalizable. Same repeated eigenvalue, but not enough eigenvectors. Truly. Repetition without productivity. Very human. But this failure is not random. The matrix is 2i plus n, where n squared equals 0. Jordan form keeps the diagonal eigenvalue part, and also records the tiny nilpotent shove sitting above the diagonal. Denial is not a proof technique. Apparently. A generalized eigenvector for lambda is a non-zero v that eventually gets killed by some power of a minus lambda I. Ordinary eigenvectors are just the case k equals 1. Generalized eigenvectors allow one or more steps before the vector finally lands at 0. Because apparently even vectors procrastinate. A Jordan chain is a list of vectors where a minus lambda I sends each vector down one step. The first vector is an actual eigenvector. The later ones are generalized eigenvectors. They are not fake eigenvectors. They are eigenvectors with paperwork pending. For our matrix, a minus 2i sends e2 to e1, and sends e1 to 0. So e1 and e2 form a Jordan chain. In this basis, the matrix is exactly the block we started with. The villain was wearing a name tag the whole time. Diagonalization fails when there are not enough eigenvectors. Jordan form fixes the story by adding generalized eigenvectors arranged in chains. Next, we will study these chains seriously, instead of just watching one defective 2 by 2 matrix cause drama.